All right. Oh dear. Sorry for the delay. Uh, it's me, Nico. Let's start. Let's start right away then, so not waste any time. So well, last time on Tuesday, if I recall correctly, we were working on this. Seems pretty good, yeah. And we needed to design the main the boards and stuff, so we could finish doing the CAD. So we're mainly going to work today on ECAD, I think. I'm not sure how much time we're gonna have to do MCAD, but yeah, we'll focus mainly on ECAD. Hold on, let me turn off Steam notifications. Hold on a second. There we go. Yeah, let's start then. So we have let's start slow. We have the receive and transmit module that we're gonna work on as one unit. Okay. Yeah, why isn't it opening? There we go. So this is basically this is the baseboard shape of this is it's the basic board shape for it. And well, where can we start? Well, first import all the changes. There's really not much in here. Validate. There's really not much stuff to do on these two boards at least. Right. All right. Because we're gonna have a jumper and we're gonna have basically a jumper board, and we're gonna have two detectors. Doesn't really matter in this case. It doesn't really matter if they're overlapping, because in the end we're just gonna we're not gonna solder them together. I should work actually to get this nice and centered. Maybe I'll need to change the grid. Still looks off. I can measure it, can't I? Well, yeah. Dimension. Wait, why is the board? Oh, because I'm in mils. Hold on. So I'm gonna change back to millimeters. Yeah, this works fine. Just to make it a little bit thinner. Dimensions. First, I want to see how. If I recall correctly, it was what? What is this? 590 by .55. Huh. So 590 is millimeters. Yeah. Right, so half of it will be. I don't really want to do it in my head, so calculator to the rescue. So the halfway point is going to be 295.275. Can I even get it? Yeah, but then I lose. Yeah, feels like this is the max I'm gonna be able to. Oh, hold on. Yeah, 295.28, perfect. Why does it keep moving a little bit? Well, I'm just gonna have to trust this. Yeah, it's already pretty well centered then. Alright. Well, I guess I can delete these then. Now, the only other thing I wanted to see was, right, on top of they're already aligned, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, sort of. No, but if I've... Right, I need to put 50, half a millimeter. Yeah, because then this gets really... Yeah, this is perfect. But the other one isn't, because this one is short. Yeah, yeah. Too short. Yeah, perfect. And then same thing, basically. So this one has 5 and then, over here. So this one also gonna have I have to have 5. Yeah, sounds good. I just want to see on the 3D model how is the 3D model for this one anyway? Is it? Oh, it has a pins. Great. So that means I can check how well our alignment is. Yeah, we can bring this a little bit up. And there we go. Now if we switch to 3D, yeah, because I want to have this flush, so probably 2 more down. No, why did I change to the schematic? 1, 2, and this should be enough, I think. Hold on, I saw something that I don't want. Properties. Yeah, I can rotate it another way, but what? There we go. Looks like 2 eyes. Anyway, switch to 3D. Close. Think one more square. Yeah, perfect. So basically this I'm already decided on the connector I'm gonna be using for the project, so I don't really, well, there's really not much of a problem if I do it like this. And so these aren't polarized, so it doesn't matter also how I wire them in relation to the other parts. So this means I can just what I wanted to do is send this to the other side though, because like this they are both in the space, so I guess it doesn't really matter once I solder them, but just to have a clear idea of what I want once I go to the CAD model. Ideally you'd want to put them exactly where it's gonna be. So switch to 2D. I want to put this on layer, bottom layer, and same thing with this one. Did this one already go? No, bottom layer. And yeah, they're gonna collide anyway, so I don't mind. Like whichever way we do it, they're gonna collide. It's important to leave your labels inside the board. Yeah, this one's good. So when we go to 3D, we should have the unit over here. We can probably make it a little bit, we can also probably make it a bit shorter too, to save space. Which we'll probably be doing. Oh, god damn it, now it's crossed the can. There we go. Yeah. So, oh wow, now it's upside down. I'm gonna have to. Can I just? What does this do? Oh, yeah, that's what I want. And I put this back on the bottom here. I'm pretty sure the lettering S1 and S2 isn't a standard thing for isn't a standard nomenclature for these, but I mean, if it gets the job done, it's only supposed to be there for indication. So J1, J2, S1, S2, perfect. Now I can kind of cut the. Can now change the board shape a little bit. Hold on. First, I want to move bring this down. No, what the hell did I just do? I can move them individually down. Yeah, I guess that's gonna have to do. Bring these down with them, because these are I'm gonna be using to separate the boards after once it's done with production. And then I can edit board shape and just bring this down like this, and voila. The board is finished. I mean, it's a little bit, it's actually a little bit big on top, so I could probably spare to bring it down a tad more. But this should be it. This should be it. Yeah, right. So you want to let me change the board, or are we just gonna be playing games here? Oh, so yeah, I'm using CircuitMaker since it's a little bit more powerful. It's free. It's a bit more powerful, and I mean it's good. Did it crash? Please don't tell me it crashed. This would be awful. This would be awful if it did crash. Right, edit board shape. So bring this down, and there we go. Yeah, we should have the board then. Yeah. Right. Yeah. So once we go on the 3D view, yeah, there is a collision. Can I just tell them to ignore the collision? I wonder. Looks okay. Looks like a decent size. How big is it? Switch to 2D. So bottom, it's to 101 Y55. On top, it's Y87.5. So it should be what, about 30 centimeters, a little bit more. I think it's pretty. No, not 30 centimeters, 3 centimeters. Tiny. Like really tiny, if you think about it. Well, the kind of stuff that we're usually dealing with is very tiny, and it's gotta fit in confined spaces. Like each one of these boards is just 70 to 85. It's just 1.5 centimeters wide, if you think about it. I will have to do some optimization later for production, but I think I can. Yeah, can I ignore this? No, I don't think I can ignore the collisions. Yeah, I'm just gonna have to go with this being red. Though, unless I modify the component, but do I really want to modify it? I mean, how is it gonna be on Nah, I think I'll just go with this. At the end of the day, they'll probably... Oh god, when I send this to production, they'll probably be screaming at me because it's, the silk screen goes out of bounds or some shit like that. But anyway, let's just ignore that. Well, routing is easy. It's just literally connecting from point A to point B. I will probably need to change. Hold on, actually. Yeah, I'll probably need to change it later for production since I'm not sure. I'm not sure of the parameters of the supplier. But yeah, no. That's gonna be a problem for the future me. 5. Huh, weird, because this one has a 1, 2, 3, 4. Oh, hold on, this one's a little bit misaligned. Whoops. Right, it's still connected though, so that's fine. And it looks like it's crying. Poor thing. Look. Oh God, how awful. And yeah, but I mean, it doesn't really do much. Once we go to 3D, it actually looks more like it's crying now. Like, poor thing. And it's, yeah, wow, what have I done? Anyways, this board is pretty easy since it's just these two connections really. The fun starts on the next one though. I'm only going to be messing with the analog detector here, since that's like that's probably what I'll end up using. Oh, and I haven't decided on the connector yet. We'll probably use just some automotive connector though, since it's going to be feeling a little bit of vibration. And actually, let me take a look at it right now. It is going to be taking a little bit of vibration, so I should probably use an automotive connector. Cavia fili, no. Yeah, honestly, I always get lost in this website. Connettori. Yeah, apparently I can't read either. Yeah. Connettori PCB. I remember seeing file di contatto. Though I'm not sure if I really want to use one of these. I remember seeing 1x T connectivity that seemed pretty okay. But, which I was actually thinking of using for the connector itself, but, you know, they don't, one of the sides, I think it was the female end doesn't have a PCB mounted part. Anyways, so I mean, I'm not really looking for a specific brand. So this has what, 6 connectors, doesn't it? Yeah, 6 connectors. Wait, why is that written J? Oh no, it's an I. Okay. 6. So, and I want to 1 row. Ideally, I want 1 row. 90-degree angle. So, angolo destro. Yeah, angolo destro. Actually, RS Pro has some nice chunky ones. No, anything more compact? Oh, is this the one? Yeah, it is. The T connectivity one I was talking about just a while ago. It is. This one costs. Yeah, you think about it with electronics, with them costing so much. I'm actually gonna get a little bit. Well, let's get a bit philosophical here, because electronics cost so fucking much. Like, what? Even if you buy a simple ass charger, I mean, the charger is a bad example because it's actually pretty complex for what it is, for what it seems like it does. But like, yeah, you buy a smartphone, which kind of seems like I'm going from one extreme to the other. But seriously, if you buy a smartphone, costs what, 800, 900 euros or something like that. Pretty much same thing for dollars, and they cost pretty much like most of that cost you're paying is pretty much just markup. Because if you go by the individual components themselves, most likely the most expensive parts are gonna be the screen and the processor. Either way, you're not gonna be spending more than what, 200 euros on them. On even like what, Let me go check real quick how much a processor costs. Processori. Yeah, I want a microprocessore. Though I don't think they have anything pretty advanced here, so I'm not really likely to prove my point. Oh, they have a few NXP ones, yeah. A little bit old. It's an ARM Cortex A9, but still, it's 57 euros at single component pricing. It's the IMX6. Yeah, it's a bit old, but still, you're not gonna be going a lot more. Broadcom Pi. ARM based. What the what the fuck? I'm actually curious what the hell this is. There isn't even a datasheet for it. BCM 2835 IFPG. Wait, isn't the BCM 2835 the one for the Raspberry Pi? Yeah, it is. Why the hell does it cost? Oh god. Oh god. I'm pretty sure that's not the actual price of it, but oh god. Anyway, yeah, my point is, if you were to like part out everything in a cell phone, it wouldn't cost nearly as much as it actually cost. And you see that these prices they actually gotta sell them in packs of 10, exactly because how else are they gonna? It would be too cheap to sell individually. Do they even sell these individually? No, just in packs of 10. Oh, this one they sell in packs of 1,000. So yeah, but you can get a lot lower price. But what am I gonna do with 1,000 of them? Anyway, so yeah, I think this one 2803.791 or 2803.792. What's the difference? I gotta check the datasheet to find out. I don't even know if they have the model for this one on CircuitMaker. Unfortunately, they make you kind of make your own stuff a lot of the time, since it's all based on cloud and crowdsourcing. I think pretty much all the components in there are crowdsourced in some aspect. I actually had to do the connector for one, but anyway, what is the difference between the 1 and the 2? 2803.791 and 2803.792. I don't see anything like oh, probably the yeah, so this one is gold plated, and I'm pretty sure this one is just yeah, it's just tin plated. So there you go. It costs how much more? 85 cents versus €1, €1.20. Honestly, I would probably just go with the 85 cents. But even if we only have the gold plated one, we can just put it. What was the product code? 2803.791. Honestly, this kind of stuff usually, if you check the step, the 22.54 millimeters, you can pretty much use anything. Though it's good to have the exact model, exact part number to. It's good to have the exact part number so you don't have to go running for it. And they don't have it. Yeah. I'm probably gonna just have to do a shitty stand-in for it. Oh boy. Because I have no idea how to do 3D modeling on this thing. I'll just do a new one. So symbol. Oh, I could probably have used an existing one, but hold on. So first I'll make 4 pins. Why are they numbered? Oh, I don't know. 2, 3, 4, 5, 6. So this is pin 1. If there was a way to change both of them at the same time, it would be great. Oh shit, hold on. I might have made this a bit of a mistake on my... Oh no, okay, they're fine. Can I change... Can I just get away with changing one number? No, probably not. Yeah, no. Unless, nope. Gotta change both. What a pain. And yeah, this is pretty much why I said that we might not be able to do some mechanical CAD today, because sometimes you just get stuck with stuff like this. I also kind of left that because I didn't want to bother looking for one, but that's another story for another time. Anyway, I will just do it real quick, you know. There we go. I want to send this to back. Can I? Huh. Can I move this to front then? Apparently not. Alternatively, I have no idea how to do. But it really doesn't give me much. A line? No. No, this is just to place options, properties. Okay, if I can't move to front, I'll probably have to place new ones. What a pain. Yeah, because now it goes well. Oh, I deleted the one I didn't want to delete. Oh boy. Anyways, pins. 9, 10, 11, 12, 13, 14, because for some reason it just keeps going up from the last one you did. 1, 2, 3, 4, 5, 6, and there we go. Should be enough. So I can save this, and it should appear. The hell is that? Hold on a second. I don't remember placing anything over there. Right, now I can save this, and it should be good. Yeah. Right, now I need to add a 2D and 3D footprint. So yeah, pad, just add pads. Can I make a square pad? Probably. Hold on, I need the step to be 2.54, so that's 100 mils. And with Imperial I can do this better. Ironically enough. I want to make this square pad, rectangular pad. There we go. Do they specify how big the pad needs to be? No, as long as it's a pad, it's okay. How thick is the 60? All right, it's a quarter of yeah, it's what, 25 mil. So how big are the holes? All right, it's all in metric. 60 mil. Yeah, should be fine. Oh no, hole size 30 mil. So we may be cutting a little bit close here. I'll increase it to 40 mil. Actually, designator, I want to put this 1, 2, 3, 4, 5, and 6. Yeah, and change the hole sizes too. I mean, it's good to have a little bit of room to make mistakes and soldering. I mean, 30 mil should be enough, even especially because the tolerances are how much? Doesn't say, does it? Finish materials obsolete. No, it doesn't. No. Yeah, it doesn't say the tolerances, so. Oh, tolleranze se non diversamente specificato 0.3. Huh? Hold on. Dimension in millimeters. So I'm guessing this is supposed to be 0.3 of a millimeter. That's a bit big, actually. No, I'm pretty sure it's not gonna be so big. So let's just say 40 mil and be done with this. I could actually take something else as an example and just copy it, but I mean, what's the fun in that? So we got the holes here. We got the. How do you mount this again? There's a 3D view, so I could use that. So how does this mounted? Right, so it's just the 6 pins and then just basically footprint. Just need to get the width and height, honestly, to make an estimation sort of. And D max. Oh, it says here. Yeah, D and B. Well, B I don't really need. 280379 this one. 03791. Here we go. So D is 17 millimeters, 17.8. Yeah. So 17.8 millimeters by. Yeah, 14.9, let's just say. Though this one has a bit of overlap with the. I probably shouldn't be doing this right now. And I also need to find which housing it takes actually. I'll have to go to TT connectivity website. Yeah. Don't have time for this now. Anyway, let's just put the 3D body in. So I really don't know how far this is from the edge. Well, it's gonna be D minus B basically. D minus B divided by half, so 17 minus 12. Oh, oops. I should really stop using the number pad. Also, the BGM is off. Yeah, I should really stop using the number pad as the. No, not divided. Divided by 2, so we have 2.5 centimeters approximately, which means we can go back to CircuitMaker. Where am I? There am I. So it's 2.5 this way. I guess we can just eyeball the other dimension. Yeah, I'm just gonna put. I mean, I should just keep clear. Anyway, so this is in the grid is in mils. We want 2.5 millimeter. Well, it's almost no difference. Actually, let me just keep in mils because it was 2.55 that we wanted, so 2.54. Wait, how many mils was the other dimension? 14.9 millimeter. So 14.9 millimeters in mils would be 500. So 5 mils, 500 mils. And then thus we go. We keep going. 3D body. So it's just estimation 3, 4, 5, because I really don't want to make a model, an entire model for this. There we go. Now we gotta add height to it. I just want to have an idea of how it's gonna look, especially because this doesn't really have much of a. This really doesn't have much of a. Much CAD function, so. And I haven't really found a way to actually upload a model to it. I don't think it actually has a way to upload a model. How tall is it? 5 millimeters, so 2. So yeah, I think I can just change to metric. There we go. So once we go to, I could add the. I should add a line too, to an outline to it. No, but I don't want this on the outline. I want it on the top paste, top overlay. Yeah, it is the overlay, isn't it? Hold on. Yeah, it is the overlay that I want. Alright, so back to my footprint. Line. It's a bit too thick for my liking. I like my lines a little bit more petite. I mean, at least to outline components. How do you think I was talking about? So I guess I gotta change that. Width, just make it. I'm not sure how thin they can make silkscreen, but I'll just make it 0.1. Should be enough. Yeah, it should be enough really. So if I save this, let me check the 3D view. I mean, it looks exactly like I thought it would, just a block. If it's accurate or not, I don't know, and I really don't care. But, well, it is what it is. I just really needed it to kind of... Oh yeah, I also needed to make a label for this, didn't I? How do I make that label again? I don't know. Oh, well, let's just save it as it is and move on. And save the server. Now it will disappear from here, but I will be able to select it later. I also want to put this kind of near the edge in order to... Right, should be saved. Yeah. Right, so you can go back to my footprint here, add part. It should be my favorites if it's anything like the other one. Yeah, here it is. Just drag it in. And there we go. Just connect. There we go. It's perfect. But this is gonna be J3. Yeah, J3. No, I don't want to change the value, just the designator. J3. There we go. There we go. Should have everything in place now. Yeah, this is the circuit we left last time. It's the amplifier and filter circuit. Sends an analog signal in. There's gonna be do some processing. Send it to another microcontroller through what was it? I2C. There's the SDA SCL lines here. Another shebang. This over here is to have the transmitter and receiver, which will be in this other board, which we just finished doing. And yeah, I mean everything. I mean, there's not much else to do. I'm leaving this amplifier here empty, but we might have to change back to it depending on how we're going to be laying out the board. Just to keep in mind. So yeah, I guess that's it. Not much else to say. Right. Now let's get on to it then. Analog detector. We want to import first import everything. I already put a hole here where I'm going to be screwing the board in place. Just label it 0 so it doesn't get in the way. Because I don't think there is a net 0. Import changes. Wow, a lot of stuff to import. Yeah, a bajillion components and a gorillion nets. So first validate, of course. Everything good, everything perfect, and execute. So now it's importing all the components in. And there we go. Well, first things first, the jumper, I'm going to leave a little bit for later. J1 and J2. So first J2, I want to put J2 at the first one I want to mess with is J2, since these two actually need to be at very precise locations. Actually, I need to know how big is the... how big is this? It should have the height. No, it just has 0 millimeters. Footprint. Doesn't say much. I'm actually gonna have to get the data sheet for these. I think I remember seeing them on Mauser. Though we should have something similar here on somewhere else. Oh no, I saw some on Futura. Let's just go there. Yay. Here we go. No. Because this one is the one actually, since they... so it's 12 millimeters tall. Which means we gotta place it somewhat away from the... 12 millimeters away from the edge. And, well, of course it's gotta be centered. Project home, here we go. I just want to draw a line on the outline, going from the center here over to here, because we gotta line this up properly. Also put a dimension in from the edge. Yeah, from here, whatever, I don't care. Wherever is fine. It's 12 millimeters. Yeah, dimensions in millimeters, right. Is it measuring in metric? Yeah. Oh, but it's measuring in... yeah, let me just put the grid at 1 millimeter. That'll probably be quicker. Because then we can just... what the hell is it measuring in? 39... No, what the hell is it measuring in? don't want board outline. Yeah. No, where did it go though? Holy. It really doesn't want to cooperate now. Okay, let's go from here. Yeah, but what the hell is it measuring in? I think the dimension's broken. Hold on, what? So I want to set the origin. Origin set over here. Alright, let's see if this works then. Dimension. Probably not, but... Yeah, I still don't have no idea what the hell it's measuring in, but it doesn't seem human. I mean, is this measuring in mils? In thou? Weird. Weird as fuck. Alright, let's just count squares. It'll probably be quicker. So 5, 10, 12. So we gotta pretty much just... how this is gonna look on the view. Switch to 3D. Yeah, this is the block that I made the other time. No, I didn't make this the other time. I made this while to prepare. So yeah, we just gotta make this a little bit more than 12 away. Honestly, the placement is already pretty good. Though, probably make the snap in. Half a mil to get a proper alignment. Doesn't seem to be wanting to align well. Quarter of a mil. I just put some millimeters then. Yeah, it looks okay. Anyway, yeah, this is probably gonna be the best alignment we can do. 1 millimeter. Oh no, hold on. Ah, shit. Let's just move this a little bit forward then. Change back to quarter millimeter. Oh, this isn't a quarter of a millimeter. And then realign it. There. Goes 2 to one side, 2 to the other side. That's perfect. Wait, with this burden out of the way, then we had the... Hold on, I actually need to check my notes for a second. Because we had concluded that for... to run it at what? This is for 1 RPM. We would have to make it 18 degrees apart. 2 RPM would be 36 degrees apart. So 3 RPM would be 54 apart. Somewhat. I'm gonna need to use the angular tool, angular measurement. I fucking swear to God, I hope it works. No, hold on. I need first select the... Yeah, here. Then here. The hell are you doing? God damn it. Yeah, this really doesn't want to cooperate with me today. Look, where the hell is it even doing the circle over here? What the hell? Look at this shit. Hold on. Alright, so I don't need this line anymore. So let me just shrink it a little bit so it doesn't get in the way, hopefully. But something else will get in the way, no doubt about it. So let's just change layer. And it's still getting in the way. Whoopity fucking do. Make a dot here. Actually, if I make a pad, just for... It should work, right? Yeah. Yeah, it works. pretty good actually. So I need it to be 54 degrees. There we go. How is it doing? Yeah, I should probably just put it in here or there. Not think too much about it. Alright, so then the next jumper, J1. I might have to resize some of the resistors too. Can I select any rotation? Yeah. So, no. 360 minus 54, it's gonna be 306. Whoops. Right, 306, so is it good now? Yeah, perfect. Wait, is it on the auto line? No, it's top layer. Oh, right, because that's the model. Yeah, I would say close enough. Though probably move it a little bit up. We're not going for pinpoint accuracy here, if you can see. Mostly because we can't really... I mean, I could. Hold on. Could probably align them pretty well. What the hell is it doing, though? It might work this time. Yes, I would like to say so. Right, this is as good as we're gonna get. Okay, what the hell? It's just going all over the place. Yeah, are we really that off? This isn't really helping. Yeah, this isn't really gonna help. Also, the measurement doesn't make much sense at all. Also, what the hell is this number? Oh, it's mils. Alright. I could just have said so first. So 567 mils to... So 567 mils to millimeters is, yeah, 14 millimeters should be fine. I think it's pretty much the same thing as I put the other place. Anyways, yeah, so you can get these angles and alignments out of here, so you can actually have some room to work with. Right, so I mean the challenge in here is gonna be just basically get everything to fit. Actually, I was thinking I was gonna make the board, this shape was too big, but I'm pretty sure that by now this is actually how it's gonna be. We don't really have much more space to play with. I could trim a little bit over here and extend it over here, but the end result would be the same. Anyway, so what do we have here? I think we should U3, since we can place it closer to that the connector. We gotta place it close to this connector anyway, so I might as well just do it. I'll probably put these thin ones on the other layer too. So, for example, yeah, I need to bottom layer. There we go. Yeah, it's gonna be a mess to get this to actually align all properly, prim and proper. But we will find a way. We will find a way. The other problem is these are through holes, so we gotta navigate around them somewhat. Alright, let's see how this goes. Yeah, I'm pretty sure these capacitors are going to be a teeny tiny bit too big. Just have a slight feeling though. These are supposed to be what, 1206s, so is that 1.2 millimeter? No, that's not 1.2 millimeter. That is right, they use mills. They use mills for this too. So a 1206 would be 3.2 millimeters by 1.6 millimeters. Yeah, we might not have enough space for that. I'll have to look for a smaller one. Though, I mean, we can always just jam the stuff in and then hope that it... which pin is ground? Just to make sure. GND is pin 15. Which means... well... hold on. First thing I should do actually is just make a pour. Polygon pour. Just pour everywhere. And yeah, that's good enough. Repour all. Yeah, didn't it go? All right, so I'll repour all. Doesn't seem to want to go. What the hell? Define from selected object. Right, so I guess we're just gonna have to... There are two poly regions though. This one is on the... should be... let's just say multi-layer for now. Doesn't seem to want to work though. I'll run a design rules check later to check it out. Anyways, gotta put this one on gotta put this one on the bottom layer too. Actually, I'm just gonna... oh, was it because I was outside of the layer? Which layer is this in? Hold on. Right, so trying again. Oh yeah, probably because I was outside of the layer. Yeah, there we go. Though I will probably want to just pour the bottom layer and make it unpoured. It's giving me a huge error for some reason. Oh well, I'll check it out later. Let's just re-pour then. Oh, there we go. Oh, this is how it's gonna look. And the point of this is just, you know, attach the pour to the ground. So just actually, can I put net GND? There we go. Yeah, re-pour now. Because now it's gonna just attach to every pin that's connected to ground directly. And it'll just be a massive, a massive help, really. Though we also gotta be careful not to. I want the entire thing. Anyway, where do we need to get this from and where do we need to get this to? This is supposed to be capacitor C8. Let me check. Right. So it's just no, let's move this a little bit back then. No, hold on. Which pin do I need to connect to? To the jumper. It's pins 7 and 14, which are pin 7, pin 14, right on the other side. Oh damn! Right, so I'll probably do well to rotate it like this, and I'll just re-pour this to make it pretty. Anyway, now we get this. No, this is weird. And we'll just start connecting stuff. Not mind too much, not minding too much. That everything's already blue. I mean, we will be able to re-pour it along the way. SW 5 volts. Okay, but these two bridge together. SW 5 volts was the switch, yeah, VCC basically. VCC and VS plus. So I can just route them like this. So there's no problem really if this just gets blocked off. Which I'll probably be doing right now actually, just to get this out of the way. Yeah, it doesn't seem to be wanting to snap very well, probably because it's 1 millimeter the snap distance. There we go. Yeah, and as always, you just gotta re-pour it every once in a while. Oh, hold on, but if we do this, we just kind of block off the jumper here. Might not be a very good idea then. Might have to want to go around. Yeah, actually, those two are the big priority here, so actually. No, change of plans. That way I don't really need to re-pour anything, just delete these. I don't need to re-pour, but... And I can also make unpoured if it does get annoying, which it will probably will quickly, but... Anyhow. Yeah, though I'll probably want to change the size of the resistors later and capacitors. Right, so 7 I will want to... Ooh, hold on. I mean, it's not directional, so I could just technically do this. Like, it's non-polarized, so it doesn't really matter which one I connect to which. Which is a big brain move in on itself. Since, well, the piezo speakers don't really matter. I don't really care what they're receiving in. Yes, as long as it's getting 20 volts on one side. Well, as long as it's getting 20 volts in total, it doesn't matter which side it's giving it. So we can just make this project, import changes, and it will compute all the changes. So remove these and add these. Yeah, validate. No problems, of course. Close. And that's pretty much how you go. That's pretty much how you go about it, really. Nothing... What is pin 8? And why is it complaining? It's RN2. Why is it complaining? I'll check the design rule checker at the end. Should give me some insight as to why it's complaining. Does it not have enough clearance for something? Huh. That's the only bad complaining, really. Oh well. I don't understand it, and I'm not gonna try to understand it right now. But this is weird, and I have no idea why. Also, I should probably move a little bit out of the way. Yes. Right. Connect the 5 volts here. There we go. Then this will need to... Wait, is this connecting? Does this connect to the port 8? Huh? No. No, port 8 is supposed to be disconnected. Oh, hold on. There's probably... Oh. Right. Yeah, that's it. Right, that C9-1 is supposed to be, well, C9. So it's just another capacitor. Which I should probably change the properties of to put it in the bottom layer. Alright, move this a little bit to the left so I can fit this one here nicely. Two big beefy capacitors. Because I think there are what, 100 microfarad. They're 150 nanofarads each. So they're supposed to be yeah, here. Probably should give them some space though. Because capacitors can get, I'm not sure if they can, how finicky they can get if they're close like this, but you know, better safe than sorry. Also, having a little bit more space just makes it easier to solder. Right. Well, there's a big problem here. Wow. No, don't want to do this. There we go. So I really want to... There we go. Yeah, because now as well it's nice and separate, the lines. Because parasitic capacitances can be a problem. Not sure if it's going to be a problem for this since it's just 40 kilohertz, but you know, better safe than sorry. Yeah, that's fine. It's because this one has a little bit of space in between. Anyways, back to our... Well, net C11. Alright, we might have to actually shift this up. Net C11 is the... Well, capacitor 11. Just connects to capacitor 11, connects to ground. So it can... do have a little bit more leeway with it. Of where we put it. Yeah, you know what? Hold on. Hold my beer. Because now I got the net C11 free to just connect it like this. And hold on. Right, we gotta send everything to the bottom layer. I have to make the grid even smaller. Apparently. And yeah, now it's starting to look pretty good. I mean, this capacitor hell here, but you know, what can you do? Then, what else can we place around this? Oh, I guess we can start to placing the power circuitry, because this doesn't really have much connection to anything else, so it doesn't really cause much problem. So now we just gotta get what, Q2, I think, or is it Q1? Q1, no, it's Q1. So I just gotta get Q1, and yeah, we're probably definitely not gonna be able to do any MCAD if we can finish with the ECAD. Right, and we can place it over here and just connect over here. Alright, so now it's connected to 5 volts. Now it's connected to 5 volt switch anyway. And up next we need C10 and R10. This one just connects like this. We're gonna need to put jumper 13 eventually, so gotta keep that in mind. And right now I'd like to make a re-pour, because I just can't see much. Oh, hold on. Re-pour all. There. And when the board is starting to get, we're starting to see the board here. We're starting to see how it's supposed to work. This one is connected to, alright, enable on the microcontroller. Which actually we should get to do. Actually, we might want to make the other connector first. So U1 is the operational amplifier, yeah. So let's get on to it. Because this one will be on the receive side. Hopefully the layout isn't too bad, honestly. Wait a minute, why is it connected to ground? Oh, yeah, no, this one is connected to ground actually. Oh, shit. So I just gotta put it in a way that... Right, the jumper, first I need R1 and C1. Probably just gonna put it over here at an angle. Like what? 2305. Yeah, that works. Alright, I need capacitor first. C1. So you got C1, we put it around here, because then we're gonna have to connect it to this. And I'll probably do well to turn it in a way that would make this accessible. Probably put a bit of an angle too. 45 degrees should be fine. Yeah, it's perfect. Look at that. Because now I can just go straight in. Might be a bit of a pain later on, but well, that's a problem for the future, me. Look at that. Looks so... Right, I need to do a bunch of bias 2v5 connections. Probably just use the middle. And there we go. Ooh, this looks bad. This looks bad. I probably shouldn't use the right angles. But alright, whatever. Well, R1 and C1 are good. R4 then? Do it one at a time. so we don't lose track. No, this is C4. I'm gonna be needing this in a while though, so I'll just keep it around. R4. So I need to connect just those two? Oh yeah, because I think it's a feedback one, isn't it? R4, yeah, it's feedback, so... I'll put this at 45 degrees too. That way we can do a little bit of magic here. Always leave enough room for stuff. Well, I mean, I guess that's a given. And look at that. Gotta save space, you know? Can't just have everything wasting space. So keep it close. Keep your friends closer, but keep your friends close, but keep your enemies closer. Well, up next is R5. Shouldn't be much of a problem. Where does it go? Where does it come from? Where does it go? Where does it come from, R5 Joe? Oh god. And let's go. Alright, it goes from here into C4, I believe. Yeah. Into C4. Which in turn goes from... Right, where do I need to go with C4? All the way over here. I wonder if I should make the longer or the short way around. Ideally you would want to keep these things short, but you can't always have what you want. Especially since I might have done the dumbass thing and just crossed everything through the middle. I guess we should just get the entire network here to check it out. So C6 and R7 and C5. No, this is, I don't need this one. C6. R7 and C5. C5 is just a feedback, so I just gotta... Oh. Do I play with vias? It might have to be. Where is R6 anyway? R5? Oh, R6. Yeah, R6 too then. Just put everything near there. And we'll worry about placement later. And that's C4-1, that's C4-2. Alright, so I'll probably want to put this here. Since C4... No, R4-2 and C4-1. Oh, hold on, can I? No, I can't stack them. What the hell am I thinking? I may be able to though. Hold on a second. Properties, I want to rotate this, put it what? 45 maybe? Yeah, 45. Will this work? I wonder. Hold on, I'll have to make it a port for this one. Yeah, but well, component placement is a big issue. But let's see if I can make this. Because now what I do is I get bias to V5, which is the 2.5 volt bias circuit. Can I contour? No, I can't use this as a shunt. Darn. Yeah, no, this ain't gonna work. I'm gonna have to find another way to do it. Although I might have some free space actually. Let's see. Let's just keep going. But in this case, I'll probably want to rotate a little bit more. What? 135? No, I want the opposite. So 305. No. Yeah, 315. There we go. Put this here. No, I wanted 135. There, perfect. Then get this one, which I'll have to connect it to bias anyway, so yeah, this is gonna be a mess of labels, but that it just is how it is, isn't it? Probably want to rotate this too. There. No, I need to make way for by net C42 too. Cause alright, this one goes from net C41 to net C52, so I should also keep it near here. No, probably just keep it 45. No, 2252. Turn this one around then. And let's see. How's it doing? Hold on. There's something weird going on. There we go. Now if we could just connect these two, I might have to do some via trickery. Let's see, 5.2 for this one. Yeah, with these beefy capacitors, I probably can pass through. Pass under them. Really makes me think. Hold on. Hold on. Might have just had a big brain thought here. Yeah, I can pass through which means I can do this whole go through all these hoops, and voila, now I just connect it like this by a steel V5 and it's all connected. Nice. This doesn't look too good though. I wanna bring it down a notch. There we go. Keep everything nice and straight. This should work. If we actually encounter any other problems, well, it's gonna be other problems. Not really much to say about them. Where's C42? C42 is over here. C41 is over here. Oh, damn. We did encounter other problems then. How are you gonna resolve this? Yeah, because now this is completely cut off. Now you see, you solve a problem, but then you create two more. Well, hold on. I can just... what was the angle again? I think it was 45, wasn't it? No, I want the 225. Yeah. I mean, solve the problem the same way I solved all the other problems, I suppose. I want to get this track, and I will... Oh god, what a mess. I might want to clear this up now, because I actually lost track of which one is which. Which one's R5? This is C5. This is R5, alright. R6. Which one's C4? Is this one C4? No, this is R10. So this should be C4, yeah. And this should be C5. Yeah. Right, I guess we did this. We managed to do it. It's so cramped over here though. And then we just gotta get this here and basically do C42 and C52. I can... No, I don't want the properties of the poor. I want the capacitor here, the resistor here. Turn around 135 for me. Yeah, that's good. Actually, no, 45. Yeah, that should be perfect actually. Because C52 is over here. And I need to connect this to... But I also need to connect this through. Can this go through? No, I'm not gonna put it close to ground. I'm gonna put on these not connected pins. And then I can get this in. And connect it like this. I don't like this hump though. Probably gonna just delete it and yeah, really don't like that hump. Oh god, this looks like a mess. And this is supposed to be R7, so this label, I'm gonna have to do some label shuffling again, I guess. Yeah, over here is fine because well, C4 is this one, so C4 is gonna be the one on C5 is gonna be the other one, the one on the bottom. C6, I need to connect 4.2 and 5.2. Oh, all right. So hold on, I can just delete this. I wanted to rotate this one, put this on 135 or not. Why is this one rotated to? Why is it so? Oh. Alright, it was 34 for some reason. Hold on, I might have just had an idea here. Because I don't really... Right, no, this is dangerously close. Still dangerously close. There we go. So, I mean, I can connect C5.2 over here, C4.2 over here, and then just pass it around over here. Everything else is already connected except the +5, the 5 volts input, which actually, do I need the +5 connected to anything? Oh, on the amplifier, no, because +5 over here, there's no other +5s, is there? Which pin is this? Pin 4. Oh, yeah, alright. No, never mind. I should have a ground pin somewhere too. Yeah, over here, but it's no biggie. Yeah, this will have to do for now. No, I don't want to move this. I want to move this. That's supposed to be C6, right? Yeah, C6. Right, you got to stay over here. Just hope this is easy to understand later. Anything else you need to connect? Just the ground. Alright. The other pins are not connected. Luckily we didn't have any problems with... Oh, pin number 8 is signal. Over here. Yeah, no problem. Oh yeah, we also need R8 and C7. Hold on a second. R8 connects to C5.2. Oh. Uh-oh. Uh-oh. Well, how can we solve this mess? Let's see. Alright, so C7-1, I could probably make, I could probably use it as a jumper somewhere. Probably not very good practice, but no, it's pretty beefy, so it's gonna have to be thicker than this. This might actually work. Should I be putting stuff so close to the pins though? Probably not. Alright, let's see then. What can I do that's mostly non-intrusive? Can I do this little bit of trickery? No, hold on, I might have to actually stagger this a little bit. And now it might work. Now it might. Oh. No, hold on. So let me move this a little bit now. Here's a little lesson in trickery. This is going down in history. If you want to be a villain #1. Oh god. I could just. Yeah, hold on. I'm gonna make another pour here. No, I just make a fill. No, solid region. There we go. It's all one big net over there. Not really, doesn't really make much of a difference, but you know, I could probably do the same over here. No, I mean, it doesn't really make much of a difference, does it? Anyway, now I need to pass this through, and I did it. Yes. A little bit finicky though. Because I mean, C7-2 is going to be over here, so yeah, it would be a good thing to just have C7-1 be already around here. Now, I might have to be just 315, yeah. Although signal is over here, so I might want to make a. Oh, I can just pass it through the capacitor. And well, and this is getting populated, I guess. Let me re-pour, just take a look at it. Yeah, look, it looks pretty good. It's getting populated. Yeah, this space doesn't get poured. I might want to make a little bit more unpoured over here, but should be fine, really. Now all that we're missing is just the processor block, the controller block. So where do we put it? We're gonna be receiving a lot of signal from here and from over here and over here. So I'm feeling up front, but then I kind of get a little bit far away from the other communication stuff that I was thinking of putting here. Though I could also put them here and just rig them through. Yeah. The pads are pretty big too. Let's see. So TX1 and TX2. I could probably pass these through below or down here. No, I don't wanna. Bottom layer. Enable connects over here, so it's fine. So it doesn't overlap with TX1 and TX2. Yeah, I think this could work perfectly. Or at least it shouldn't be too bad. I will pass enable. No, because I gotta pass IRQ later. Right, so enable is connected. I want to connect TX1, TX2 next. There we go. Why isn't this? Can I just shift this a little tiny bit down? Yeah, that's perfect. Right. So this chip is already good. Next, we should be looking at the rest of this chip. Really. We got signal, which I gotta connect to over here. Which we can just bridge through here. And I think that's just plus 5 volts. It's gonna be a common. It's gonna be a common rail. It's just gonna be the voltage rail. Should probably just get signal for now. Why does it put these weird bands? I guess it's just program quirks. Leaving a space so in case we need to run something else through. There we go. Because we might have to run plus 5 volts, I'm not sure. Through here. Right, next, actually I'm probably just gonna place this over here. Properties. I think that angle was 270. No, not 270, but jeez. There, 225. So I'm just gonna put the connector around here. Should be fine, I think. How's it gonna look on 3D? I mean, it's gonna look like a big block because I didn't do the connector properly. Yeah, it looks okay. All the other stuff is on the other side. It's gonna be a pretty compact board. I'm feeling. Anyway, so we have plus 5 volts, which is gonna come in here. I want to change the pin order too. SDA SUL is fine. IRQ is also going to come in. Oh, okay. No problem then. GND is going to be a general pin, and UPDI is going to have to go all around. So I'll probably do a through hole for that one. Right, so first things first. Let's go from bottom to top. I'm putting UPDI on the top layer. And I run it through to here, so it doesn't get in the way. I'm gonna make a via. And then finish routing through to here. I mean, if there is any room later, I will be more than glad to just run the UPDI without doing a via, but if it comes to this, I'll just leave it like that. Ground, I don't think I need to do anything for now. I'll just see how it behaves. Well, IRQ is going to have to go here, which is the interrupt request. SDA and SUL. Right. And let's just put it over here. It probably lined up almost per, yeah. No, hold on, but then this, right. And then there's the problem with the plus 5 volts. Which I can probably find a way to fix. Let me do a pour real quick just to check how. Yeah, alright, ground connect. Is this pitch proper? Probably. Anyway, let's see. I'm feeling around the plus 5 volts. Do I really want to run a plus 5 volts on a... yeah, I'll think about it. For now, let me just finish connecting everything. I also need to put in the clock. The clock crystal somewhere. Yeah, I'm feeling we're running out of space here. No. Might want to get a smaller capacitors, because I'm currently carrying these are how big were they? 1206s. Yeah, 1206s. Because I mean the clock isn't even gonna fit. Unless I really move it to the other side of the board. And it's a through hole too, so... Actually, what if I just rotate it a little bit? Use it as a sort of jumper. No, but then I'll have a lot of trouble trying to get it in. Let me give myself some space then. Over here. Yeah. Which pin is this? It's signal, isn't it? Yeah. Make it a little bit more compact too. Or else you can't really fit the clock in here. Where did I put the clock? Here, the crystal. I'm feeling that we're gonna have to put this on like this if we want to. If we want to rotate it, or if we want it to fit, at least. Then I need the C12 and C13. Yeah, you were supposed to be. Oh, hold on a second. I think I did something wrong here. Give me a second. Oh, oops, yeah. Did a little whoopsie here. I'm gonna move these grounds a little bit further in. Oh. No, because I still need to connect SDI here. Reminder to always check your schematics. But I guess if you do end up catching your stuff before you actually commit to it, then I guess it doesn't really well, it doesn't really matter much as long as you catch your stuff. Anyway, so that C12, it's gonna be this one. Right, so the C12 too, I gotta connect here. This is IRQ, isn't it? Yeah, so I'm just gonna, and C13 is gonna be this one. Right, up next we got the two capacitors, C12 and C13. They don't really give me much space to jump, so they are connected to ground, so I can just do the... They are just connected to ground, so I can just do this. And then put a ground plane on the other side. No, but I want the top layer. I want to draw on the top layer, this one. There. And this solves a big problem too. I'll just make another pour for the top layer. Because, I mean, there is some stuff here that I think I could connect to the ground like this, and would probably not make much of properties. I wanted to net this to ground too. There. Once the bottom layer goes on top, it's going to be pretty much like this. R13 is connected to IRQ. Be through. Oh, because it's the pull-up. Yeah, I think I'm gonna make the plus 5 volts. Oh no, but in this case I can't really. Yeah, I think I'm gonna have to pass the plus 5 volts through the top layer too, if I wanna make it like this. This one is gonna go on the bottom layer though. And do this. Because like I can just route it like this. And there we go. It's an interrupt on plus 5 volts. Doesn't really matter if they're shorted too, so which is good. Because I mean, no, if it has a pull up, it's gonna be a bit of a problem. Anyways, it should be okay. Next, we've got some other big beefy components for the filtering, input filtering, yeah. Also SDA and SCL pull-ups. This is SCL, alright. Yeah, I'm feeling like these two need to go to plus 5 volts, so where's the other SDA? Yeah, here's the SDA one. So I'm feeling like I'm gonna do something like this. So they're both sort of aligned. Plus 5 volts is in another state though. Then we just need C14, C15, and I think we also need to make this bias network, yeah. So I'll leave the plus 5 volts line on the top layer. No, wrong way around. Because these are just filtering caps for the input. I should re-pour all. Okay, hold on. This is conflicting with UPDI here. Yeah, now it's good. Okay, because if I make no, it still won't get in, and I needed to basically. Alright, what do I need to get it? Plus 5 volts, which connects all the way over here. So in theory, I could just make. Alright, so for this one, I'll probably just route it like this. And hold on, because this looks like straight up Dookie. Now it's good. Yeah. Okay, so this one is connected. Now I just need to get it in here and over there, because these two aren't connected to anything, and I need to connect it to all the way over here. Yeah, but this is basically isolated from the outside world, isn't it? I'd have to pass it through here. I wonder, should I? Yeah, I guess I'll try to do it, just do it. I mean, as long as it doesn't, as long as I don't get complaints about design rules, it should be fine. And no, it's pretty okay. I think I could get it a little bit farther away from there, honestly. That's just, well, I also need to set up the bias, 2.5 volt bias network, which is going to be over here. Hold on, R9? Did I forget to put R9? Ooh, oh, ah. Awful, awful. How am I gonna fit this in here? I feel like I could do this like this, but it probably would be a bad idea. Well, let's see. Can I clear up enough space for that? First things first. Maybe. I don't really need to pass the signal through here. I can just... There. Alright, I managed to put R9 in. Now I think this is just... yeah, that's just the... Now it's just the bias, the 2.5 volt bias network. which I actually did on my previous project, have to make a bias network, so it's nothing really new. Anyway, so first thing, I should get the plus 5 volts in. Just goes to show that I will need to at least make yeah, I might as well just where was the plus 5 volts anyway? Over here, alright. So I'll try to lay it out in a way that no, there we go. Try to lay it out in a way that doesn't really conflict with the plus 5 volts. There we go. Then I just need to route the plus 5 volts all around, and we should be done actually with this board. There we go. Now, what did I need to do? Oh yeah, just connect the power to the other side. Well, I mean, so what I will do is, we already have the plus 5 volts running through to here. Can I move the UPDI a little bit closer in? Yeah, probably. I just want to I just want to get rid of this kink. Yeah, all right. So I got UPDI over here, which means I can. Yeah, that's what I'll do. I will still pass it through the top layer, but hold on. Yeah, but because I forgot to fix this part. There. Yeah, so I'm still gonna pass it over the top layer, but Because we're gonna need it around where? Here. Yeah, hold on, I should probably make the via before. Yeah. Yeah, this works. Then back on the top layer, we can just go straight through. And there we go, this should be good. This is the board. We used almost all of the board space, so I'm guessing I'm not gonna cut anything off. I'm not gonna be able to trim anything. How does it look? All right. I'm also gonna change the pours a little bit. Polygon pour. Alright, I'm gonna want to delete both the pours so I can give a rigorous definition of the pour. So define from selected objects. Yeah. Oh right, because I also got a I gotta put this on the ground net. Weird, it doesn't cover everything. Probably just leave the pour like that then. Oh, because it needs to be solid. Right, there we go. Perfect, now it doesn't really do much more than it really doesn't occupy a lot more space. And then we are also going to want to pour the top layer. Oh. Yeah, of course. So did it do it? No. There we go. There we go. Yeah, let's look at 3D at the 3D then. Oh, that's how it looks. Oh, I don't like that this is too it's closed like this. Hold on, can I change the pour settings a little bit? I wanted to make it hatched. What is hatched? Oh, it's just... Yeah, I guess I'll just leave it like this then. Doesn't really make much of a difference if it's touching the border or not. It's ground anyways. There's probably a more efficient pathing for this too, but actually I wanted to see if can I pass the UPDI in another manner instead of having to go through this. I'm thinking not. Because I mean, if I go in through here, yeah, if I change IRQ and ground, it doesn't really make much of a difference, does it? I mean, I could probably put UPDI IRQ ground. Let's check if it changed something. Yeah, then I got fucked by the plus 5 volts here. Anyway. No, I'm feeling like I'm gonna just leave it like that, honestly. Yeah. I'm just gonna leave it like that. I guess with this we're done too. No, but then there's a hole here for on the corner. Oh, hold on, I can probably move this a little bit lower. Yeah. Yeah. Hold on. Can I? No, no, because the plus 5 will go through there. There, this should be fine, because it also gives a little bit of an edge here, a buffer. Yeah, I'm feeling like we're done then. I'll leave with this. Then we gotta, I will do a prototype beforehand and get it to production before getting to, before actually sending it out to printing. So, well, keep an eye out for that. I mean, the bottom side is pretty simple. Well, the top side is pretty simple, but the bottom side is where the magic's at. I actually should change Q1 and R10. Oh yeah, we are getting a little bit. Right, so well, let's focus first on where it matters. Q1 needs to get out of there. R10 too. Well, at least not on the fingers. J1. All right. We also have a little bit of confusion here between R6 and what appears to be R8, or Well, R5 is completely nuts. Yeah, all this part is fine. It's just R5, R5, R6, R8, and something else. Yeah, here we go. Right, which one was R8? This is R8. Alright, so this one gets to stay here. Then we have R9, which I think was that new one that we put, which is this one. R6, which should be this one, yeah. Alright, so let's see if I can move it a little bit over here. R9 I'll move down here. R5 was this one. R5, yeah. Right, U1 I'll move out of there. There we go, should be, yeah, I mean everything is sort of in place. Huh? Something's missing here. Is it R7? R7, where is R7? Here. Yeah, it's R7. Oh, R7 is missing. Looks good if I say so myself. Then I can save this. I'll save it to the server, so I don't lose all my work. Save this one too. And I want to output. I want to export. Actually, let me do a design rule check first. Run the RC. Unrouted net NetBIOS to V5. Where? Oh, hold on, it got disconnected here. Whoops. Always run the design rule checker before saying you're done, because you might find something like this. Now, if we run the design rule checker, it's giving me empty, so it's good. Perfect. No more changes need to be done. So we can, yeah, save again. Feel like I don't need any comments here. I wanted to generate a 3D model though. Step. I also already exported Gerber files. Well, the schematic, PCB. The bill of materials, I wouldn't really say it's so important because I'm not going to be using the exact components. Yeah, also Gerber files, and I'm not going to do pick and place. It's going to be just, yeah, I'll generate those. With this, in theory, you should be able to just get the Gerber file, which I'll post below, and start making it. Actually, I do need to post everything below, don't I? Should I publish it to CircuitMaker.com? Then it will be public. I might. It's gonna take a while, so I mean, while we're doing that, I might as well go to CircuitMaker and see if I can make it, if I can publish it. Sign in. Hold on, I might want to put this here. So I don't get any Well, unsolicited emails, really. My components. Okay, yeah, I can just share the project here. So let me go to my where do I find my? Oh, yeah, my email just shows up there. Altium 365. So I should have the, yeah, I'll just share these. Publish to CircuitMaker. All right, yeah, perfect. And I'll post the links below in case you want to see. It should have all the project files. Should have all the project files too. So to be used in conjunction with the analog or digital detector. It's in development, I would like to say. Not really anything on galleries. I won't put a description for now. License. Honestly, I'm just gonna put a CC BY. I don't know, maybe non-commercial. Nah, just put the least restricted. I mean, it's my work, but I don't really mind if other people want to do something with it. My project, shared projects. So yeah, analog detector is also here. Yeah. Can I edit and maybe put the license here? I also put CC BY. Don't really mind much. Components. Are just in the board. Are just indicative of size and value, and it should not be and can be changed at will. All right, it's in development. Hey, perfect, save. So I guess I got my first two. Guess I got my first two projects in, huh? Anyways, while we're here, I want to save and commit changes. Yeah. Yeah. Right, it's generating a PCB print, the PDF 3D, up to date. The Gerber files are up to date too. So if you want to go and produce this for yourself and just to test, should be done, yeah. Oh yeah, I need to edit something in the description. Which one was the resistor that was subject to change? R9 is subject to change. R9 is not a set value and is subject to change. There we go. I'll also make all the same things for the RxTX module. Project, generate outputs. So yeah, schematics, PCB, PDF 3D, Gerber, and step. And meanwhile, I might edit the description right now, actually. Now I find the details and schematics of my project on my Altium account. So I want, where is it? Yeah. CircuitMaker.com. There we go. Look at that. My first public work, huh? It looks like it's fucking crying. It's fucking depressing, man. I swear to God. Is it generating outputs yet? No, it seems to be stuck still. Doing whatever it is it wants to do. Oh God. Yeah, this is a bit tiring. Guess we're just gonna have to leave the mechanical CAD for another time. Jeez, oh man. Are you done? No, it's still churning. Number crunching. Because now we also, oh yeah, save and commit changes. Okay. Alright, all good. Did I release the other one? Oh shit, I might not have. Oh damn. Project has been released successfully. Hold on, let me regenerate it real quick then. Might not have done it properly. Give me a second, it's gonna take a while here, unfortunately. But yeah, the project should already be on CircuitMaker.com. If you want to take a look for yourself. It looks fucking rad, the schematics and PCBs and stuff. Right, so we can release it now, yeah. Alright. So yeah, we've got our first project released. Wait, look at that. Releases. So yeah, the Gerber file is what you use to make it. The export step is the 3D model, which is what we're going to be using next time. You can even see the PCB online if you want. You don't need to be... Yeah, why is J3 all the way over there? Hold on a second. Come back here. Right, there's not going to be a J3 in the release. But the J3 is going to be safe. So if you just... can you download the Gerber files directly without it being released? I wonder. Probably not. I probably can, but... downloads... yeah, you can. I can download the Gerber directly, but... This is my personal space, and I don't think other people can actually see it. And it still hasn't updated, actually. Oh well, it'll eventually update. But yeah, this is basically it. Wait, where did I put J3? Uh-oh. Right, anyways, yeah, this is it. This is it for this one. I can't flip it though. It's missing the outline. Oh. Looks good, doesn't it? And if you look in 3D, wow, R7 is still missing for some reason. Yeah. Yeah, and I think anyone can open this, I suppose. Not sure. I hope so, or else I'm just gonna have to download everything and put it on my on the GitGud. So yeah, let me know in the comments below if you can actually see it. But for the rest, I guess this is it. Yeah, thank you guys for watching. If you leave a leave a like. If you made it this far, it's kind of late, I know, but I mean, what can I do? But if you liked, leave a like. If you disliked, tough luck. Don't forget to subscribe if you wanna keep following me on this, and I guess we'll see you next time.